Then question number 3, okay, of exercise 3.7. So here we are assuming that the speed of the train is x kilometer per hour and the actual time taken is y kilometer per hour. Okay, so the train speed and time are unknown. And we know this formula that distance is equal to speed into time. So speed we had assumed as x and the time as y. So whatever happens to the speed and the time, the distance will always be a product of speed and time. So that will be xy. Okay. So here we've got the distance as xy. Now what happens? You increase the speed, the time taken will be less, because when the speed is faster, you will reach your destination faster. And if you decrease your speed, what will happen? The speed will, if you decrease the speed, the time will increase. But whatever you do, the distance is a constant. So distance is going to remain xy. So speed and time are given there in the question that if the speed is increased by 10 km per hour, then what happens? The time becomes less by 2 hours. Because when we increase the speed, obviously the time taken to reach the destination will be less. So here the speed is increased by 10, so x plus 10. And what happens to the time? It's decreased by 2, so y minus 2. The product of speed and time will give you the distance, and distance is a constant xy. Whatever you do with the speed or the time, the distance will remain xy, right? So this is a constant. Now when you open the bracket, this will become xy minus 2x plus 10y minus 20 equal to xy. Xy will get cancelled from both sides. And what are you left with? Minus 2x plus 10y equal to negative 20. We transfer this side 20. Now we can take 2 common. So minus x plus 5y equal to 20. So minus x plus 5y equal to 20 upon 2, 10. So this is our first equation. Now what is happening? They are decreasing the speed. Now when you decrease the speed by what is given in the question, decrease the speed by 10. Then what happens to the time? Time is increased by 3, because when speed is less, time will increase. But however, the product of speed and time will always be giving distance, and distance is a constant xy. Open the bracket, xy plus 3x minus 10y minus 30 equal to xy. So xy is getting cancelled from both sides. So 3x minus 10y equal to positive 30. So we have 2 equations. Now this you can solve by elimination. Multiply this by 3. So when you multiply by 3, you will get minus 3x here. So we can add it up because the signs are already different. So when you add this, we get 5y is 60, so y is 12. And substitute the value of y is 12 in any of the equations. I have substituted in 1 here. So you will get the value of x as 50. So if x is 50 and y is 12, what is the distance? Distance was the product of speed and time. So x multiplied by y, so we get 50 multiplied by 12, that is 600 kilometers. So we can say the distance is 600 kilometers. Then question number 4 is somewhat similar to this. Here what is happening? Students of a class. Now students of a class is again a constant, just like distance was a constant in the previous. So what is happening? Let the number of students in one row be x. Now in our classes we also have rows, no? So in one row, if 10 students are sitting, and if there are 4 rows, the total number of students in the class will be 40, right? So the logic is we just see how many rows are there and how many students are sitting in one row, and if I multiply both these, then I'll get the total number of students. So if total number of students is x and total number of students in one row is x and the number of rows is y, then what can we say? That the total students of the class is xy. So this logic is clear, I suppose, right? So again I'm repeating this. We are assuming the students in one row as x and the number of rows as y. So total students will be xy. Okay, understood? No? If in one row there are 15 students and there are 3 rows in the class, so total students in the class will be 15 into 3, 45. So number of students will never change. But what we can do is that change the arrangement. So if we have less students in one row, the number of rows in the class will increase. If we have more students in one row, what is happening? The number of rows will decrease. So these are inversely proportional. So here, according to the question, what is happening? The number of students in one row is increased by 3. Okay, you are adding 3 students more in one row. So what is happening? The number of rows will decrease. And how much is it decreasing by? It's decreasing by 1. So here there is an increase of 3 in the number of students per row. And here what's happening? The number of the rows has decreased. And the product of number of students in a row and number of rows will give you what? the total students in the class, that is xy, right? So you get this first equation, that is x plus 3 multiplied by y minus 1 equal to xy. Now open the brackets here. So xy minus x plus 3y minus 3 equal to xy. Now xy is getting cancelled. So what is left here? Minus x plus 3y equal to minus 3 will transfer this side, so positive 3. Same way for the second part. What is happening? The number of students per row is decreased by 3. So you are decreasing the number of students in a row. So what will happen? The number of rows will increase. And how much is it increasing by? By 2. So x minus 3 into y plus 2. Again, number of students in the class is a constant, that is xy. So when you open this, you get xy plus 2x minus 3y minus 6 equal to xy. Now xy is getting cancelled from both sides, and then we get this equation 2x minus 3y equal to positive 6. So these are our two equations. Okay, already the y coefficients are same, and in fact the signs are also different, so no need to change any sign, just add it up. So we get x is equal to 3 plus 6, 9. Substitute the value of x as 9 in any of the equation, we get the value of y will come 4. So total number of students in the class will be the product of x and y, that will be 9 into 4, 36. So total students in the class will be 36.